Good evening to you all once again. My name is Mr. Adebola Emmanuel Bolan. I'll be your chemistry teacher for today. Before now, we know chemistry is a branch of pure science that deals with the study of matter. And matter is anything that has mass and can occupy a space. Everything around us are made up of matter. The clothes we put on, the water we drink, and even the air that we take in from the atmosphere. But for today, it's a different topic entirely that we are going to be looking at. And the topic for today is stoichiometry. And what is the meaning of stoichiometry? Simply, it means calculation in chemistry. So what is the definition of stoichiometry? Stoichiometry is a branch of chemistry that deals with the measurement of the quantities of reactant and product in a chemical reaction. Let me come again. Stoichiometry is a branch of chemistry that deals with measurement of the quantities of reactant and product in a chemical reaction. So, if you look at what we have on the board, we said stoichiometry is a branch of chemistry that deals with the measurement of the quantities of reactants and products in a chemical reaction. And stoichiometry is founded on the law of conservation of mass. Yes, stoichiometry is founded based on the law of conservation of mass. That is, mass of reactant will be equal to mass of product. And if you look at what we have on the board, we have reaction of methane and oxygen. Methane plus oxygen to give us carbon dioxide and water. So A can represent methane, B can represent oxygen, C can represent carbon dioxide, and D can represent water. So methane and oxygen will be the reactant. Then carbon dioxide and CO2 will be the product. So we want to know what is the amount of methane that can react with oxygen to produce a given a certain amount of carbon dioxide and a certain amount of water. So, but the chemical equation is CH4 plus O2. O2 is the oxygen. Then CH4 is the molecular formula for methane. Then carbon dioxide will be CO2, then plus water, H2O. If you look at the equation, you notice that the equation is not balanced. Here we have H4. That is, we have 4 atoms of hydrogen. So you come here and put 2 as a coefficient. Immediately you put 2 as a coefficient. Coefficient is the number that is attached to H2. You can see the 2 bigger than this one that is small. So 2 multiplied by 2 means we have 4 atoms of hydrogen at the product side. And here we also have 4 atoms of hydrogen. Then for the oxygen, these 2 affects everything here. So we have 2 oxygen with another 2 oxygen making 4. Then in order to make this to be 4, you put 2 at the back of the O2. So we have 4 atoms of oxygen. So if you want to relate it now, we have 1 mole of methane reacting with 2 mole of oxygen to give us 1 mole of carbon dioxide and what? 2 mole of water. So you have 1 at the back of this place, but it's not necessary. So 1 mole of methane reacts with 2 mole of oxygen to produce 1 mole of carbon dioxide gas, of carbon dioxide and 2 mole of water. So then we want to know the reacting mass. The next thing is to know the reacting mass. Now that we know the mole, we have to know the reacting mass. That is, what is the mass of methane? that reacts with a given mass and what is the mass of oxygen, what is the mass of carbon dioxide, and what is the mass of water. And at the end, the mass of reactant will be equal to the mass of product. And what is a mole? A mole is the basic unit of measurement in chemistry. Just like we can have 1 crate of egg, 1 gallon of palm oil, we can also have a mole of a substance. And 1 mole of a substance contains 12 grams of carbon. 1 mole of every substance contains 12 grams of carbon, and 1 mole of every substance is also equal to the Avogadro number. Thank you for your time. We are going to continue in the next class.